All right, so in this video, we are going to work with our class survey data, looking again at the number of states visited by our students. And we are going to pretend that our class survey, that our sample is a simple random sample of Clayton State students. That's pretty iffy, but for illustration purposes, it's fine. All right. Okay, so in this particular case, we are answering the question, is there strong evidence that Clayton State students have visited fewer states than the national average of 11? All right, have they visited fewer states than the national average of 11? So there's really our question, our alternate hypothesis. Okay, so implied in that is that obviously that the national average is 11 states, and if Clayton State students are no different than the national average, then their average should be 11 too, right? So this is CSU students no different from national average. All right. Our alternate, of course, is that we think they've visited fewer states so that the mean is less than 11. Okay, so we'll just make that a CSU. Visited average less than 11. I should write out less than, right? Okay. All right, so of course we should sketch, but at this point we don't know what the sample mean is, so we need to go pull it up in Geogebra. I'm going to pause while I do that because it's going to take me a minute. So remember, we're going to go to the three horizontal lines. We're going to go to File, we're going to go Open, and you're going to do Local File, find where you saved that file, right? I have mine all pretty much saved in a data files directory, and I think in GeoGebra format, but I'm going to pause while I go find it. Oh, look here, I found it. It's right here, Spring 2026 Stats Survey. So we're going to open that, and always asks you, do you want to save? No, I don't. Okay, so sometimes it will automatically switch to the spreadsheet perspective, sometimes it will not. We are looking at states visited, so I've got to go over and find that. There it is. So, and remember, we need to make a histogram and then do our statistics, right? So go to histogram, one variable analysis, go to the little icon that looks like a histogram. And we don't, we can see here, it's definitely not a normal sample. We don't know anything about the population, but it's probably not normal either. So we do want to make sure that our sample size is bigger than 30. Okay, so let's pause for a minute here. Well, okay, we've got the mean, 8.0833, and our standard deviation, 6.0543. Okay, so I'm going to write those down, right? 8.0833 for X bar, S, our sample standard deviation, 6.0543. And our sample size was 60. So now we can make our sketch. We're going to want to check our conditions, right? But our sketch 11 should be at the center. Our actual sample mean 8.08, and we are shading to the left because we have a less than. Okay. Now, I don't think, this one doesn't ask about conditions, but we should check conditions, right? And of course, we want to know, is it random? And here we're like, yes, no, not really. We're going to pretend, right? Pretend it is, but, not really. Is our sample bigger than 30? Yes. Is our sample size less than 10% of the population? Again, yes. So, yeah, okay. So the random one's super iffy, but the others are okay. And this is a class example, so we're just going to go with it. All right, so we need to calculate the test statistic. We're going to do this by hand, and we're going to do it with technology, okay? By hand, we have all the stuff we need. Now, are we doing a Z? We know we're doing means because we see that it says average, right? So we're going to say, hey, we know it's means, but is sigma known? Do we know the population standard deviation? No, right? The only number given in this problem is the claimed population mean, and the only standard deviation we know came from the sample, so it's the standard deviation of the sample, S. So sigma is not known, which means we are going to use T, right? So our test statistic, T, let's go to a different color, because why not? T equals x bar minus mu over S over root n, right? So we've got 8.0833 minus 11 over 6.0543 over root 60. And, there's going to be some variability in your answer here depending on how much you've rounded. So I am going to go over to GeoGebra and hopefully remember all those numbers, but probably not. So we're going to go to our graphing calculator view, 8.0833 minus 11 over S, so 6.0543 over square root of 60. Let's double check and make sure that those numbers are right. Hey, I remembered them. So our z-score, negative 3.73. It seems a little, I think it defaulted to 2 decimal places while I wasn't looking. Yep. I would say, keep 5 at least, maybe more. Oh wait, I think I need, there we go. So negative 3.731. Now let's go with 2, negative 3.732. Oh, and you know what we forgot to write? Because as soon as we figured out that we were doing a t-score, we should have written down df, right? Which remember is n minus 1, so it's going to be 59. All right, now we got to figure out our p-value, right? What is our probability of getting a sample mean less than what we got, 8.0833? And we're going to have to go back to GeoGebra and look up our t-score. All right, so 3.73, is that what I wrote? Yes, 3.732. Okay, probability. Remember, we're doing a t-distribution, so you got to change this to student t-distribution. And our degrees of freedom was 59. We are doing a left-tailed, a less than, and it was negative 3.73, I've forgotten, 732. So what is our p-value? Really small again, right? 0.00021. Now, and I did not give you an alpha level again because I like to be able to do whatever the heck I feel like in class, right? So, but does it matter on this one? No, because our p-value is smaller than the smallest alpha level we would reasonably pick. So even if we go at a 1% alpha level, our p-value is still less than that. So we will reject the null. What does that mean? That there is strong evidence that CSU students have, on average, visited less than 11 states. We don't know how much less, but we know it's less than 11. Now, but we have the data on this one, so, I did it this way so that, we've exercised our thinking muscles, but we can let the computer do this for us, right? I'm going to go back to our spreadsheet view. And apparently we're going to have to go redo our, there we go, states visited, make the histogram, calculate the statistics. And then we can go to this pull down menu. We are doing a hypothesis test, right? And so either a z-test or a t-test, but we were doing a t-test. And our hypothesized mean was 11, so we're going to put that in. Our alternate hypothesis was less than 11, so we're going to select that from the drop-down. And look, our p-value matches exactly out to 5 decimal places, and our t-score matches to 3 decimal places because we remember we rounded ours. It's giving us our DF of 59, our standard error, S over root n. You know, we calculated that, but not really. That was our part of our denominator, right? That was our denominator. And it's giving you the mean and the sample size. So it gives you all the pieces that you need. But when you have the data, this is a much easier option, right? And there's no problem with doing it that way. Just make sure that you are able to go through and show all the steps, you know, to calculate that z or t score yourself and find the p-value using your normal calculator, right? Or your student's t-distribution, right? Whichever one. Because either way, even there, oops, oh, you can make it do both. Interesting. Even here, I gotta go redo it again. It is not telling you the conclusion, right? So when we did this t-test of a mean, and we put in our mean, and we put in our hypothesized mean and our alternate hypothesis, it's not telling us what to do with that p-value. It's not saying, oh, reject the null, and what does that mean? You have to remember how to do that, right? And that's why we have to practice. All right, that's it for this example.